In this lesson, we're going to study the dot product. The dot product is a way of multiplying two vectors. If our vectors are in two dimensions, so if A is A1, A2, and B is B1, B2, then we define the dot product A dot B to be A1, B1 plus A2, B2. So we just multiply the first component of each vector, multiply the second, and add them together. In three dimensions, we do the same thing. We just have a third component for the third component of each vector. So notice that the left-hand side, we're multiplying two vectors, and the right-hand side is just a number. So the dot product of two vectors produces a scalar or a real number. So the important thing to remember here is that the dot product takes two vectors, multiplies them, and gives you a number. So let's do a couple examples. So here we've got two vectors in three dimensions. So if I want to do A dotted with B, that means I do 0 times 2 plus 4 times 4 plus minus 3 times 6. So I get 0 plus 16 minus 18 or minus 2. So A dotted with B is equal to minus 2. So notice we took our two vectors, did the dot product, and got a number minus 2. Now let's do B dotted with A. So for B dotted with A, I'm going to do 2 times 0 plus 4 times 4 plus 6 times minus 3. So again, I'm getting 0 plus 16 minus 18, which is equal to minus 2. So it should be pretty clear to everyone that no matter what vectors A and B we take, A dotted with B is going to be the same as B dotted with A. So if we look at the definitions, if we do B1 A1 plus B2 A2, we're going to get the same thing as A1 B1 plus A2 B2, and similar in three dimensions. So A dotted with B is equal to B dotted with A. And so that's this property of the dot product that I've listed here. One of the most important properties of the dot product is that a vector dotted with itself gives you the length of the vector squared. So let's look at the proof of that. So how does that work? I'll do it in three dimensions, but of course it works the same in two. So if A is the vector A1, A2, A3, so I know that A dotted with A, so I do A1 times A1 plus A2 times A2 plus A3 times A3, which gives me A1 squared plus A2 squared plus A3 squared. Now what is the length of A? So remember the length of A, that's just the square root of the sum of the squares of the components, so A1 squared plus A2 squared plus A3 squared. So the length of A squared is just A1 squared plus A2 squared plus A3 squared. So I see that A dotted with A is in fact equal to the length of A squared. And this is going to be, again, a very important property that we're going to use many times in the course. So you'll want to remember this property. A dotted with A is the length of A squared. It'll also be useful to remember that A dotted with B is B dotted with A, and then I have some additional properties of the dot product here.